Welcome back to Code Meets World, and today we're actually going to work on the first medium difficulty problem that we've seen so far, which is the rotate image problem in the math and geometry category. So this is LeetCode number 48, rotate image. And we're given an n by n 2D matrix representing an image. We need to rotate it by 90 degrees, which is clockwise. And we have to rotate it in place, meaning we have to modify the 2D matrix directly. Do not allocate another 2D matrix to do the rotation. So this is going to be much easier to show on the whiteboard what's going on here. So let me switch to that. Right, so let me show a smaller example first so that we can visualize what this rotation is actually like. So I like to think of it as like a die, like a square that you can roll, just because that makes more sense in my head. But what we're doing here, I think, is rotating this 90 degrees so that we end up with 1, 2, 3, 4. We're going to end up with it like this. So we're basically, if you think of it like a square, like a die, and you rolled it onto its side, which is what I'm trying to show here, that's what we need to end up with. And now they're just rewriting that with the numbers right side up, so it's easier to read. I've already messed it up. 3, 1, 4, 2. So these are the same thing. But what we're doing is taking so like here, we're taking whatever we're given and we're just rolling it onto its side. And that's what we have to return. So it sounds kind of easy just looking at it, but the interesting part here is we have to do it in place, which means we can't just say, okay, given this input one, let's make a new one. And then we know because of the results that we need to take the first value and we need to put that here, and we need to take this value, we need to put that here. We're not allowed to just fill it in like that. We have to do all the manipulations on this original input matrix. So we're going to need to do some swaps to switch stuff around, is basically what it's saying. Right, so how can we do this in place? We can use just 2 steps to make this happen. If you've studied matrices before, you may have heard of the transpose operation. And the transpose operation simply replaces rows with columns. And I'll show you what I mean in a second. Replaces rows with columns. So for instance, if we have the matrix 1, 2, 3, 4, if we transpose that, what we get is we take the first column, which is this, and we turn that into the first row of the new matrix. So it would go 1, 3. So we've turned the column into a row, and we do the same thing for the other one. We take 2, 4, and we write 2, 4, like that. So this is a transpose. It switches the rows and the columns. And transpose operations are used in linear algebra and mathematics to rotate matrices. So if you look at this, the result here, we didn't quite do what we wanted, because the solution we would like to get if we were to rotate this one 90 degrees, we want to get we want to get that. This is what we want the solution to be, but instead we're getting this when we transpose. So we need one extra step, which is to switch these values. Because if we switched these, well, I guess I'm doing it in the wrong place. We need to switch these values. Because if we switch these values, we end up with the correct final answer. So it's clear that we need to do a transpose operation and we need to do some sort of reversing of the numbers. And that'll get us to our final solution. Now, the transpose operation stays the same every time. The reversing operation, because there are some mathematical tricks that have been evolved over the years to solve these sorts of problems, we can actually do the reversing part first by switching the order of the rows of the matrix first and then transposing the result. So let me show you what that looks like, and let me do it on the actual input that we're given in the example to showcase how this might work. So we know we need to do a transpose, but before, because transposes rotate matrices, but to get this to work and rotate 90 degrees, the first thing we want to do is switch the order of the rows. So basically, we want to switch these two. So we get 7, 8, 9, 4, 5, 6, 1, 2, 3. If this had another row, like that, we would do it instead. We would switch these two, and then we would switch those two. So if there's an even number, we switch all the rows. But if it's an odd number, like we have in this example, we just do this big switch out here because there's nothing to switch the middle one with, so we leave it the same. So once we switch, now if we do the transpose on this matrix, remember we do it on each column, making that the new row. So 7, 4, 1, 8, 5, 2, 9, 6, 3, like that. And this, you'll notice, is if we take this matrix and rotate it on its side once, like we rolled the dice over, that gives us this one here. And if we go up to here, those are the same. So we can see the steps are first to switch, or maybe reverse might be the better term, rows of the whole matrix, and then the second step is to do a transpose. And if we do those two things, we'll be able to rotate the matrix 90 degrees. So now let's go ahead and take a look at how to do this in Python. Okay, so to write this, we know we need to basically do two things. The first of which is to reverse the rows. And the second thing we need to do is transpose the matrix. So we'll start out by reversing the rows. I think what'll make sense is to keep track of the length of the matrix. The length would be the number of rows in the matrix. So I'll call that L. I'll set that equal to the length of, is it just called matrix? Yeah, it's called matrix. Like that. That way we don't have to keep computing it a bunch of times. And then we'll say for row in range L, like that. We need to flip all of the rows like I showed on the whiteboard. Meaning for this example here, we would need to flip the first row and the last row, but not the middle row. So we know we need to do the number of swaps we need to do is equal to the length, so the number of rows, integer division by 2. So the length here is 3, but if we divide that by 2, we get 1.5. But remember, integer division, we drop the decimal, so we just get 1. So that means we need to do 1 swap. If the length was 4, 4 divided by 2 is 2, so we know we need to do 2 swaps. So I think what I can say here is if L, or if row, so meaning the one that we're on, equals, or is less than, actually, we can say is less than L divided by 2, meaning, because remember, L divided by 2 in this case is 1. So if row is less than 1, meaning only for row 0, we do a switch. We can say that, and remember, we have to do this in place. So we need to do a swap. So I need to swap matrix row. And by the way, if you've never done a swap in Python, there's special syntax for that. We can say A, B equals B, A, and that'll swap the values of A and B in place. So I'm going to do that here with the first row and the last row. So this is the first row we want to swap. The second row we want to swap is matrix. It's the length of the matrix minus 1, of course, because the length is 3, but if we did the index 3, that would be out of bounds. But then it's also minus row, right? Because if, in this case, it's just length minus 1 minus row, which is 0. But if we're swapping a bigger array, or a bigger matrix, and we're somewhere inside of it, to get the row that we need to swap with, we start on the end, but by subtracting row, which is increased each time, we will move backwards through the matrix. So we're always swapping the next level down. Let me know in the comments if that doesn't make sense, and I can try to explain it a bit better. But we want to swap those with, now we just write it the other way, L minus 1 minus row, and matrix row. So that was how we reversed the rows. Now we need to transpose the matrix, which, as I mentioned on the whiteboard, means we have to take each column and make it into the row. Now we could do that, but that code would be probably a little complex. So let me actually really quick show the code for transposing a matrix, how we usually do that in Python, because it's slightly different. The way I explained it originally was that we take each row or each column and make that the row of the new one. So there's the first column, here's the second column, and here's the third column. But there's actually another way to do the same thing that's a lot simpler. And to do that, let me write it again. We can think of transposing as rotating the matrix around the diagonal. And this gets into some linear algebra, which I'm not going to explain. But if we hold the diagonal constant, the diagonal, of course, is this chain of values here in the middle. If we hold the diagonal constant, all we need to do is swap the values around the diagonal. And what that means is we take these, let me get a different color. We take these two and swap them. Then we take these two and swap them. And finally, we take these two, oh no, sorry about that. We take these two and we swap them. Notice if we do that, we get a 4 here, and a 2 here, a 3 here, and a 7 there, and a 6 here, and an 8 there. And we see, oh, sorry. I was like, that's not right, but that's because I did it wrong. The swap, we get 2 there, 4 there, 3 here, 7 there, 6 there, 8 there. Sorry about that. And these two are equal, meaning we completed the transpose. So now going back to the code, that series of swaps is much easier to write the code for, in my opinion, than actually swapping the rows. So we can say for I in range L again, same as up there in the reversing code, But then we need to do it on another layer. So for j in range I, if you want me to make a separate video showing how this code does what I just showed on the whiteboard, I can also do that. But basically, we're looping over the rows, and then within each row, we need to make one swap around the diagonal. And so this one is looping over the starting value for the swap. So what we can do is simply say matrix I j, and again we're going to use the swap syntax, so matrix j I, and that's going to equal matrix j I matrix I j, a lot of brackets here. And because we're doing this in place, we don't have to return anything. And actually it says that up here. We're modifying the matrix in place. And this down here transposes the matrix by swapping the values around the diagonal. Does that make sense? Hopefully. Let's go ahead and run that and see if it works. It does. So let's submit. All right, fantastic. So that works. Pretty short amount of code, but theoretically there's a lot going on here, especially if you have never seen any linear algebra or matrix math before. This can be pretty confusing. So let me know in the comments if you want to talk more about matrix operations or do more matrix problems, or even go over some of the linear algebra of how this exactly works or why it might be useful. But yeah, that is the rotating a image problem. Thanks so much, and I will see you in the next video.